So good afternoon to all of you. I hope my audio is clear and my screen is also visual. Okay. So let's start with our new session. Not confidently say ki new session, but there are some portions that has not completed yet. So we just complete the some few remaining portion, such like as oscillation and wave motion. And we also try to cover and fill up some voids that will help to overcome some conceptual clarity in class 12th standard. I hope it is clear to everyone. My audio and video is clear. Okay. So beta, we assume that we all are going to enter in class 12th. What is the scenario, what is the curriculum, and what is mindset that we have to require to study the physics of class 12th. Okay, because one thing I would like to clear is the chapters and the sequence and the conceptual clarity is most important thing in the physics. Okay, so how we can create our thought process for a given chapter, because the 11th and 12th is the totally different by nature and by their chapters also. In 11th, more and less we discuss about the mechanics, thermal and wave portion, but in class 12th we more inclined toward the electrical section. Okay, what is the electrical section? We more interested. We want to study about the electrostatics. What is the current? What is the current electricity? What is the magnetic field? And there are some applications out there and modern physics. Okay, so that is the totally different. In 11th, it is possible to feel the situation. Suppose, sir, if this force is acting on this bar, so this is our force, this try to pull the body. But it is difficult in class 12 to feel in that manner. Okay, so before going to class 12, more or less, we just complete our remaining portion of class 11, because this chapter is the very important for class 12 also. Why this chapter is important for class 12? We need to understand this beta. Why this chapter you have taken, sir? Because this is acting like as a bridge. There are probability of each and every chapter, they can mix the problem of the oscillation, because oscillation is involved in each and every chapter of physics. Okay, what is the oscillation, what is the properties and the characteristics of oscillation, why oscillation is happened, what is adversities that arises due to oscillations, we need to understand better. Okay, there are some physical significance of oscillation, that's why we study oscillations. Okay, so just start the oscillation. And what is the outline of the today's session? Whatever we are going to study in the today's class, beta. First of all, we have to understand what is the meaning of oscillatory motion. Then what is the qualitative nature of SHM? How SHM is happened? What is the SHM? The next, what is linear SHM? How we can write down the equation of linear SHM? Then basic terms related with SHM, such like as we already know amplitude and velocity, acceleration. There are phase difference. There are multiple terms we already know. Different types of graphs that involve in SHM. How SHM can make a easy. What is the uniform circular motion in the SHM? And our last topic of today's class, that energy in SHM. So without wasting the time, let's start the beta SHM. So before going to study the SHM, we just have to understand the meaning of the periodic motion. Okay, whatever doubt, if any query, you can comment in chat box. Okay, without any problem, beta, you can comment in chat box. Okay. So what is periodic motion, beta? Periodic motion is nothing but, beta, that is the, we are familiar with this motion since our childhood. If a motion that repeats its path after a fixed time interval, such type of motion is known as the periodic motion. Okay, sir, very good. It means we can say here our planets are involved in periodic motion. Okay, this is also correct because they perform, we can say, if you consider circular orbit, a circular motion after a definite interval of time, they repeats its path. So we can say if in our wall watch, agar if we consider in wall watch, so we can say ki our needle of the minute hand and second hand also perform periodic motion. You can say yes, sir. If we consider a pendulum and if we release a pendulum from this point, pendulum will also oscillate in this manner. This is also an example of periodic motion. What is the periodic? Which repeats itself after a definite interval of time. So what is the time period? First of all, if anybody asks to me what is the time period? Time period means minimum time interval after which motion repeats itself. Sir, we can say that there are 2 revolutions, 3 revolutions, 5 revolutions, but we have to find out the minimum time. Suppose if we consider if this is our earth, so if our earth is, suppose that if earth start motion from this point, say this equal to t equal to 0, then find the time when earth again reaches at this point. The time taken by earth to reach at this point, that time is known as time period of the periodic motion. I hope this is clear to everyone. I hope that this is clear to everyone what is the meaning of the time period. Okay. So in this manner, we have to proceed. Firstly, we have to understand meaning of the periodic motion. I hope for everybody periodic motion is clear. Okay, beta, periodic motion is clear for everyone. Give a thumbs up. Give a thumbs up in comment box if periodic motion is clear to everyone. Come on, guys. Yes or no? Come on, give a thumbs up, yeah, guys. Let's move for what is the oscillatory motion. Sir, what is the oscillatory? Why oscillatory motion is come into picture? We study the periodic motion, na? Humke beta, it is not necessary. We always study a same type of directional motion. What happened in this case? Earth always rotate. If we consider Earth always rotate in this manner, Earth is not going to change the direction of its motion, sense of motion. Suppose if we move in clockwise, always it moves in clockwise. Yes or no? But if such type of motion in case B, this ball is firstly move in this direction, then again this move in this direction. So what will happen here? The motion direction is continuously changing. Once this is going in this word, again this is going in opposite direction. So in such type of motion where to and fro that is possible, such type of motion is known as the beta oscillatory motion. Okay, if we define it in systematic manner, then how we can say that it is not necessary to and fro motion of any particular system is called oscillatory motion. So to and fro oscillatory, yes sir beta. Whenever to and fro motion occur, let us understand this concept beta. When and to and fro motion occur, such type of motion is known as beta oscillatory motion. Such type of motion is also known as beta oscillation. Okay beta. Sir, we can understand if we consider a spring mass system. Okay sir, we consider it. Suppose that mass of block is m, spring constant is k. Okay sir, if somebody applied a external force on this block and assume that constant force applied at this end of block, then what will going to be happen? If after some time application of force, if we remove our force, then what will happen with block? Anybody in chat box, what will happen with blocks? block will move something like this. Block will move something like this. What is happening, beta? Block is performing forward, backward, forward, backward. Such type of motion is nothing but to and fro motion. Yes or no? I hope this is clear to everyone. Sir, so such type of motion is oscillation. Yes, sir. What is difference between the periodic motion and oscillatory motion? Sir, in periodic motion, sir, in periodic motion, we can say that they repeats its parts after a regular interval of time. What is the example of periodic motion? Sir, circular motion. In our watch, that is always repeats its path, circular motion. Oscillatory motion is also a periodic motion. Yes, sir. It can be provided that they repeats its end point. Let us understand with this example. Suppose beta this is pendulum, or suppose if we release pendulum from this point, and suppose pendulum is reach at this point B. Okay, this is the first round. Pendulum is moving in such a way. Correct. What will happen in the second round? Pendulum is only reach at this point, and here pendulum is only reach at this point. Then what will happen? Firstly, pendulum will reach at this much distance, but in the second case, pendulum will reach only this distance. And the third case, this angular displacement is continuously decreasing. So can we say that the pendulum bob can repeat its path and touch its endpoints? No, sir. Continuously, its magnitude of amplitude that continuously decreasing. So we can say that this is periodic? No, sir, because here loss of energy involved. So that pendulum cannot touch its end point again and again. I hope this is clear to everyone. So if we want to make our oscillatory motion to periodic motion, then what we have to do? We have to assume that there is no energy loss. There is no energy loss in surrounding by any means, by air resistance, by friction. We neglect all type of losses. Once we neglect all type of losses, then we can say that, sir, our oscillatory motion is behaving like as a periodic motion. So that point is very, very important, and that is the, we can say, punch line here, beta. It is not necessary that end points are always fixed. देखो बेटा, end point continuously changing. शुरुआत में end point A B, again C D, end points are changing, so it is not necessary. But if end points are fixed, then every oscillatory motion is become periodic. I hope this is clear. And this happen only when total mechanical energy is conserved. That is the important concept that I want to discuss here. One more thing, beta, write down this thing, beta, and if you want to take an screenshot, you can take. Whenever oscillatory motion happen in the dunya, that force, this force is always equal to minus kx raised to power n. If some force having such type of equation, minus kx raised to power n, such type of equation is basic characteristics of oscillatory motion. What is meaning of this? Sir, what is this force? This force is known as the beta net restoring force. Net restoring force. What is the meaning of restoring force, sir? Sir, a force which always want to bring the object its original position, its mean position. That type of force is known as the restoring force. Okay, sir. Sir, what is the meaning of restoring force? Can you explain me in brief? Okay, let's see beta. If we consider three cases, suppose if we container something like a bowl and a ball is placed at this bottom. In second case, if we consider bowl in such a manner and a ball is placed at the upper top surface of this bowl. Okay, same one thing. In the first case, if we displace the ball, say what about here? Equilibrium is happen or not? You can say, sir, mg is acting downward, normal is acting in upward direction. So at equilibrium, normal is equal to mg. So one thing we can clearly mention here, if bob having mass m, ball having mass m, then both the case mg is balanced by normal force. So in the both the case, the body is in equilibrium, sir. But we want to know in which case body is in stable equilibrium. In which case body is in stable equilibrium. Come on, guys. Can you tell me? Beta yaar, come on, yaar. In chat box you can mention. My screen is not visible. My screen is not visible. Okay, beta. Okay. Sorry, beta. Sorry. Now it is visible or not? Sorry. Now it is visible or not? Sorry for that, guys. It's my mistake. Now it's visible. That is the some network issue because of this happened. Okay. Now this is visible or not? Please ensure that now screen or PPT is visible or not. Satish, Vishal, can you please tell me my screen is visible now? Yes. Thank you so much. Okay. So what I want to say, okay, let's start. Sir, in work power energy, we have a basic idea about the nature of equilibrium. If we consider two cases, that is the case one, in such type of concave surface, a ball is placed. Let's see here, a ball is placed. So we can say that here ball is in equilibrium, no problem, normal is balanced by mg. In the second case, again, if we consider the convex type of surface, again mg of ball is balanced by normal force. So we can also say that this net force is 0. So we can say this is the case of the equilibrium. But if we want to interested, sir, in which equilibrium that is stable, that tells about the stability of the ball. So what is your answer, beta? What is your answer? So you can say, sir, what is the meaning of stable equilibrium? Sir, meaning of stable equilibrium means body possesses its minimum potential energy, or we can say that if we slightly displace body from its given mean position, body want to regain its main position. That is the concept, beta, super concept. We can say that is game changing line. We have to understand this, beta. Yes. That, sir, what you want to say, if we displace this ball in either direction, suppose if you want to displace in rightward direction and just give a small impulse to ball and leave the ball, what we can say that body will always settle down its original position. Are you agree with me? Or not, beta? Yes, no. This is happening or not? Yes, sir. But what happened in this case? Sir, if we slightly displace ball in this case, body हमेशा के लिए अलविदा कह देगी, बेटा. Yes, no. कभी भी body will never regain its original position. That will happen in the second case. So in which case we are more interested? That is stable. Which one is the stable, sir? First one. Oh my God, this is nothing but this is the stable equilibrium. Oh my God. So what is oscillation, beta? Oscillation is nothing but that is the story of stable equilibrium. So first thing we have to understand what is oscillation. That is part second, part 2 of stable equilibrium. Okay, सर वेब सीरीज बन गई क्या? यस बेटा, वेब सीरीज बन गई. पहले पार्ट में वर्क पावर एनर्जी स्टेबल इक्विलिब्रियम एंड सेकंड पार्ट ऑफ स्टेबल इक्विलिब्रियम इज नोन एज द बेटा ऑक्सीलेशन. कितने बच्चा लोगों को क्लियर होता दिख रहा है बेटा? एक बार थम्स अप कर दो यार. कम ऑन गाइस. What is the oscillation? That is the basic funda, stable equilibrium. If we want to further study of stable equilibrium with giving some initial displacement, that is the oscillation. Okay, beta. Let's move for the next. Sir, Let's discuss with the example, sir. Okay, let's example with that. If we want to say that, sir, whenever such type of force that F equal to minus kx raised to power n come into picture, where if we consider minimum value of n that n equal to 1 beta, so we can say that, sir, which force is responsible to bring the ball in original position? If we displace in this direction, which force is responsible? This force is responsible, beta, this force. And this force is known as restoring force. This force is known as restoring force. Okay, sir. Sir. What is K here? What is K here? What is X here? Let us understand. If in this equation we put minimum value of n, that n equal to 1 here, that n equal to 1, such type of oscillation, if we put n equal to 1, so this will become easy to study, because this is nothing but a straight line relation. I hope this is understand for everyone. This will become a straight line, and we know that we are more comfortable in study about the straight line characteristics. Such type of oscillation where value of n equal to 1, such type of oscillation beta is known as SHM, simple harmonic motion. Yes, beta. What is SHM? That is the special type of oscillation where n equal to 1. Where n equal to 1. What is the F? Restoring force. What is X, sir? What is X? X is nothing but वही slightly displacement जो आपने बॉल को दिया है from mean position. What is the mean position, beta? Mean position is the position of equilibrium, जहां पे बॉल पे नेट फोर्स 0 होता है. तो जो आपने बॉल को slightly displacement दिया है, that displacement X is always taking from the mean position. So what is X, beta? That is displacement of block or ball from main position. I hope this is clear. From main position. What is another name of main position, beta? What is another name? Sir, that is equilibrium position. What is K here? K is known as, beta, SHM constant. So, beta, here we have to understand what is the SHM. SHM is nothing but special kind of oscillation where the amplitude is small, and in order to make oscillation SHM, we have to put n equal to 1 here. Okay, let's take one example in spring mass system. How this is happen? Let's try to understand. Then come our original point. Okay, beta. See here. Suppose if we consider a spring mass system, beta. Say this is our spring mass system, and initially there is no force is applied. So we can say spring is in its original length. If spring is in its original length, so there is no spring force, because we already know spring force is nothing but, beta, K into X. बेटा बहुत लोगों को दुनिया में डाउट होते हैं कि F equal to KX क्या है बेटा. This is the spring force बेटा, where we have to take X from the natural position. क्लियर कर लो बेटा, X कहाँ से लेते हैं बेटा, ये X क्या है बेटा. Sir, this is the spring force. Here X is always taken from the natural position. Sir, so this is our natural position. Okay. Now, if we applied a external force here, and consider if we applied a constant force here, then what is going to be happen? Sir, if we applied a force, then spring want to extend. If block move in rightward direction and spring want to elongate, then spring force come into picture. Okay, if spring force come into picture, if we draw in lower side, let's see beta what will happen. Suppose due to this force some elongation occur in spring. This is the natural position. Say this is the elongation. Say this is the x1. Okay, this is the constant force. Say this is the constant force. Suppose that 10 Newton. No problem. This is the 10 Newton. What is the spring force that acting here? Sir, spring force is always measured from the natural position. This is the natural position, and this x1 elongation occur in spring. So this force is nothing but kx1, and spring force always want to bring the spring in its natural position. This is the funda. This is the funda, beta. Okay. Sir, what will happen? Initially spring force is 0, so F is dominated. If we apply the value of constant force F, then gradually spring force continuously increasing. Then what will happen बेटा? बेटा एक टाइम ऐसा आ जाएगा बेटा जब स्प्रिंग फोर्स इनिशियली 0, 1, 2, 3, 4, 5, 6 कभी ना कभी स्प्रिंग फोर्स की वैल्यू बेटा इस एफ के इक्वल हो जाएगी. आर यू एग्री विद मी बेटा? आर यू एग्री विद मी? देन दिस इलोंगेशन इज द एक्स नॉट. Whenever this spring force equal to external force F, this is nothing but beta, this position is known as the equilibrium position. I hope this is clear to everyone. This is clear to everyone. If this is the equilibrium position, then what will happen at equilibrium position? We can say F equal to kx naught. It means net force on block. Sir, net force 0, leftward equal to rightward. So what is the acceleration? Sir, 0. What about velocity? Sir, velocity is also 0. ना बाबा ना. एक्सीलरेशन को देख के कभी भी वेलोसिटी के बारे में कमेंट नहीं करना मेरे लाल. We have to see that sir, in the whole process the block must possess some speed. So in this position block having some speed also. Okay, even this is the maximum speed. How, sir? After this point what is going to be happen? After this point F is constant. F is constant. Say this is the 10 Newton and this kx naught is also become 10 Newton. After this point what will happen? Elongation is again increases and this value is only 10 Newton. Suppose this value will become 12 Newton. Then in which direction net force is acting? You can say, sir, in leftward direction. Sir, net. After equilibrium position, net force is acting in leftward direction. Okay, sir. Acceleration is acting in leftward direction. Okay, sir. But velocity is in rightward direction. So what is happening here? Velocity and acceleration continuously opposing to each other. It must, kabhi na kabhi block will attain its 0 speed. So at some point, because acceleration is opposite to velocity, at some point speed of block will become 0. Why 0, sir? Because acceleration is opposite to velocity. As we move the block, elongation is continuously increasing. So spring force continuously dominating over the constant force. And this point, this acceleration will become maximum because this is the maximum dominating force of the spring and speed will become 0. Sir, speed 0. So can block will move in rightward direction? No, sir. Speed will become 0 because for motion speed is responsible. Then what will happen? Block will turn back from this position. And if block will turn back, then velocity is acting in this direction. Okay, sir. Acceleration is also acting in this direction. Then again velocity and acceleration in same direction. Its speed is increases. And again block will reach at mean position. Then again speed will become maximum. Then what will happen beyond the mean position? Beyond the mean position, external force is acting in rightward direction. Okay, sir. Now spring force will become less. So now external force is dominating. Acceleration is acting in rightward direction. Again, speed will continuously decreasing. At this position, speed will become 0. Okay, sir. So what we want to say that, sir, is, sir, this is extreme position where speed of block will become 0. This is the left extreme position where speed will block will 0. And this is the mean position. It means if you want to conclude, the block will perform its motion between two extreme position. And this extreme position, we can say that in horizontal plane, right extreme position, this is the left extreme position, and this is the mean position. I hope this is clear to everyone. I hope this is clear to everyone how this type of, now I am taking only a single example of the SHM, how SHM is happen in the spring block system. The similar type of SHM is happened in the pendulum also. Okay, beta. So what will happen? Sir, we must know three positions. One is the extreme and another is the mean. and the distance between mean position to extreme position, that is known as the beta amplitude. I hope this is clear to everyone, beta. Yes, Anu. What is the amplitude? Sir, this is nothing but that is the distance of mean position to extreme position. In another word, we can also say that sir, mean is acting like as a divider. That's why we can say mean. Okay. So we can also say that the distance between two extreme position, if we divide the distance by 2, we will get again amplitude. I hope this is clear to everyone. Okay. So what important point we have to understand, beta, is suppose from equilibrium position always take x equal to 0, because in the SHM always measure the distance from the equilibrium position. If we displace our block slightly in rightward direction, okay, and say that the block having some velocity v, so if block will perform SHM, so there must be a restoring force acting in downward opposite direction, and this value is nothing but F equal to minus kx. So what we have to understand here, beta, x is always taken from the mean position in SHM, and what is the k? Not spring constant, that is the SHM constant. So what is the meaning of negative sign, beta? Ki sir, if displacement is right direction, force is in left direction. If displacement in left direction, then force is right direction. अरे restoring मतलब कोई तो लाएगा, कौन लाएगा बेटा? जो उसको लाएगा, that is the restoring. So this word is written here. We have to understand the magnitude of force should be directly proportional to magnitude of displacement. Let's talk about beta how equations come into picture. Let's see, sir. Once we understand here, this net restoring force is nothing but minus kx. Okay, sir. What is k? We can say that is the SHM constant. Okay, beta. Sir, if this is a single force, okay, so this is the net force. Yeah, and net force is always written mass into acceleration. Oh my God. Okay. So we can say this is nothing but a equal to minus k by m into x. Beta, k by m is important for s. Why, beta? Because this characterizes the property of the system. So this k by m for given time we assume a value that omega square. In later class we understand why we assume omega square. So if we say that this a equal to minus omega square x, okay, sir. Sir, if we want to develop a relationship between the velocity and x, how we can develop? Let's see better. How we can develop? Always draw. This is mean position, x equal to 0. This is the stream, right stream, x equal to plus a, x equal to minus a. What is happening in right stream? Sir, velocity or speed is 0. Speed is 0. Here speed is maximum. Here speed is maximum. It is clear. Is it clear to everyone? Why speed is maximum? Just consider the spinning block system. Okay, because acceleration and velocity both are acting in same direction. I hope this is clear. Sir, total mechanical energy is conserved. Oh my God. If total mechanical energy is conserved and velocity is maximum, it means kinetic energy is maximum. If kinetic energy is maximum at the same time for conserving the total energy, what about potential energy? Anybody in this class? What about the potential energy? Sir, minimum होने ही चाहिए, because logic also, because this is the case of the stable equilibrium. Okay, it means at mean position, kinetic energy maximum, potential energy minimum. Sir, at extreme position, speed is 0. So what about the kinetic energy? Sir, kinetic energy will become minimum. So what about the potential energy? That will become maximum. The same thing happened here. One more thing we have to see here. Sir, we develop a relationship here. So acceleration is also written as v dv upon dx. I hope everybody aware about this formula. Sir, just k by m. मेरे लिए बेटा k by m को ओमेगा स्क्वायर अभी बोलो, बाद में हम देखेंगे why we consider omega square. Sir, acceleration v dv by dx. Sir, we can write down na. Yes, because we know that if you want to acceleration in the form of time, then dv upon dt. If we want to this relation in the term of displacement, then v dv by dx. Sir, we want to develop a relationship between v and x. See beta, see, बहुत पते की चीज बता रहा हूँ बेटा. See here, just collect similar type of variable in one packet and another type kind of variable in another packet. Okay, v dv similar type. Okay, omega square x dx similar type. Any problem beta? No sir. Sir, what is the meaning of this? Sir, meaning of this is this x equal to 0 and suppose our particle is here at a distance x from main position at any time t beta. What is the velocity of particle v? We would like to know what is the velocity of particle. How we can know, sir? Sir, we just integrate this because we know small velocity. So in order to find out velocity at time t at a displacement x, we have to integrate this. Sir, how we could put limit here? Sir, one thing we know that, what do you know? At stream position, velocity is 0, speed is 0. Okay, it means at x equal to plus a, your speed is 0. Yes, sir. Sir, and what you would like to know? Sir, what is our speed at a distance x? Suppose that at distance x, this speed will become v. I hope this is clear. How we can put limit here? Please give me a thumbs up, beta. Please give me a thumbs up. Is this clear for everyone? Okay. Sir, if we integrate this, how we can integrate, beta? We know the formula in 12 that x raised to power n is nothing but x raised to power n plus 1 divided over n plus 1. We are also going to take a basic mathematics class for you guys. So don't worry if you can't understand this. Okay. But for today class, you can remember this formula. X raised to power n dx is nothing but something like this. We can say that this will become v square by 2. And how we can put the limit beta? Once we have to put upper limit, then put minus sign, then again put lower limit. Here, if we put limit, if we omega square is constant, we can put outside the integration sign. What is the x dx? X dx in this formula, an equal to 1 here. So this will equal to x square by 2. Okay, sir. And if we put limit a and x, I hope this is clear. If we solve this beta, once we have to put upper limit, c, come on, see. In place of b, put v square. In place of v, put 0. Okay. Here, in place of x, put x. So this will become x square. In place of x, put a. That will become a square by 2. Okay, 2 cancel out. And I hope v square is nothing but beta omega square a square minus x square. If we arrange this term, that v equal to omega under root a square minus x square. I hope this is clear to everyone. This is nothing but we develop a relationship at displacement x from main position. What is the speed of the particle? What is the speed of the particle? अगर आप हमें displacement बताओगे, हम आपको speed बता देंगे. बात खत्म. I hope this is clear to everyone. Yes or no? Sir. One more thing. If we want to write down the acceleration, that we can say acceleration is nothing but minus k by m into x. Net force equal to a. So this is nothing but this is omega square x. So this is relationship between the a versus x. One more thing we want to develop beta. What is the relationship between velocity and time? X and time. We want this. X is a function of time. How displacement is vary with time? कैसे करेंगे बेटा? लेट्स से बेटा, अब तुरंत माइंड में क्लिक होना चाहिए. वेलोसिटी को टाइम का फंक्शन बनाना है. ओके, हाउ वी कैन डू दिस? एनीबॉडी इन दिस क्लास? हाउ वी कैन थिंक अबाउट दिस? सर, वी कैन से दैट की वेलोसिटी वी कैन राइट डाउन हियर dx upon dt. Okay, so this will become omega under root a square minus x square. Sir, dx upon omega under root a square minus x square को एक साइड प्लेस करो. क्यों सर? Because x want to in one side. This will become something like this. If we put dx divide over a square minus x square, this will become omega t. see one more thing, beta. In basic mathematics, in most probably in this Sunday and Saturday, we are going to take your basic mathematics class. So there is no need to worry. If you don't know how we can integrate this, just think, okay, it can be. Okay, beta. Let's see, beta. If we want to find out the displacement, beta, say that ki beta, say that ki beta. If we want to integrate this is the standard integration, and this is the integration of sine inverse, beta. Sine inverse. Just see here that sine inverse x upon a. And here this is the omega t. One constant, because sine inverse is nothing but that tells about the angle. So if we put an angle phi here, so this equation x upon a, something like this. If we transfer sine inverse in right side, this will become sine omega t plus phi. And this x equal to nothing but beta a sine omega t plus phi, beta. देखो बेटा, मैंने तो ये तक दिखा दिया how we can develop this relation. X is nothing but a function of sine. Okay, this is the sine curve. Plus minus. Okay, this gives a feeling of oscillation. What is the phi here, beta? Let us understand. Sir, x equal to a sine omega t plus phi. What is phi, beta? Phi is known as, beta, initial phase. Initial phase means, sir, where is our particle at t equal to 0? That is the initial phase. What is the omega t plus phi, beta? This is known as the phase constant. This is known as the phase constant. I hope this is clear. If you know basic differentiation, just differentiate this and we can find out the value of velocity. If we differentiate this, what is the differentiation of sine theta? Cos theta. Okay, so we can say this will become a omega cos omega t plus phi. Again, if we differentiating this function, we will get acceleration. What is the differentiation of cos theta? What? Minus sine theta. Okay, good. So we can say this will become, and omega is constant and this will associated with variable. So we have to again put outside minus omega square sine omega t plus phi. Okay, sir. So this is the motions parameter in the terms of time. So, sir, what we learn here? One thing we have to learn, what is the velocity in terms of x? What is the velocity in terms of time? What is the equation of SHM? That is the standard equation we always write down, x equal to a sine omega t plus phi. What is the omega, beta? Sir, this is the omega is nothing but, beta, that is the under root k by m. Listen, and this is nothing but, beta, this is known as your angular frequency. Your angular frequency. I hope this is clear to everyone, beta. Yes, Yano? Let's talk about the graph, beta. Sir, acceleration versus displacement graph. Okay, we can draw. We know that net force equal to, beta, minus kx. Okay, and net force is nothing but, beta, what we can write down net force? What we can write down net force? M into a. That m into a equal to minus kx. So a can be written as minus k by mx. How we can predict about the graph, beta? Sir, x having maximum power 1. A having maximum power 1. So graph is straight line and with negative slope. So I think this is clear to everyone. Yes or no? This is negative slope and a straight line passing through origin. Put x equal to 0 here. What is the acceleration? 0. Put x equal to plus a here. What is the acceleration, beta? That is the, if we put x equal to a, this value will become minus omega square x. Put x equal to a. If we put x equal to a, beta, this will equal to minus omega square. This is nothing but that is the maximum value of acceleration. See here, this is the maximum value. That is minus omega square a. This is the maximum value of acceleration, omega square a. So if we interested in magnitude, what is the amplitude? What is the maximum value of acceleration? Anybody in this class? Omega square a. In similar manner, what about the velocity, beta? V equal to omega under root a square minus x square. In order to put the maximum value of speed, put x equal to 0 here. If we put x equal to 0, it means we will stay at origin. At origin, this value will equal to v equal to a omega. V equal to a omega. This is nothing but maximum velocity, maximum speed of particle. I hope this is clear to everyone. Okay. So what is the equation of speed? That is the last topic. Then we are going to end the class, because today is the class after, we can say that after 15 to 20 days. So there are some laziness, and we can say that there are some barriers also in this class. So from tomorrow class, we must attain a momentum and cover this topic very thoroughly. Okay, beta. So what is the beta graph between velocity and displacement in case of SHM? Anybody in this class? Sir, we know the equation v equal to omega under root a square minus x square. How we can develop the relation? Sir, we have to develop a relationship between v and x. So if we squaring both the side, v square equal to omega square a square minus x square, what will happen? V square omega square a square and omega square x square. If we transfer v square omega square x square and omega square a square, whenever such type of term into picture, both the variable having two power, always see either the curve is ellipse, either the curve is circle, either the curve is hyperbola. I hope this is clear to everyone. Whenever curve is in this manner, we can say the such type of curve is circle. Whenever curve is something like this curve is known as the ellipse. Okay, sir. Whenever curve is something like this is nothing but hyperbola. Okay, am I correct, beta? Sir. If we make right side 1, then what will happen? Omega square x square, omega square a square, v square, omega square a square, and this will equal to 1. This will equal to, beta, see here, x square divide over a square, v square divide over, oh my god, such type of equation that will match with the equation of ellipse, where x is nothing but our the major axis, and v, that speed is in vertical minor axis. This is what is a square, beta. That is, we can say what is semi major axis, that is a. So this coordinate will become a comma 0 minus a comma 0. This is semi minor axis, that is the square root of, just compared with v square, that is a omega and minus a omega. So what is the nature of graph between velocity and displacement? We can say that this is nothing but ellipse. I hope this is clear. So in today's class, we just learn about the kinematics of the SHM, how SHM come into picture, what is the concept of the time period, how periodic motion come into picture, how periodic motion different from oscillation. Every type of periodic motion come into oscillation, or every type of oscillation come into periodic motion. Just think about this, some type of basic thing. We have to connect with a term that total mechanical energy is conserved. If total mechanical energy is conserved, then each type of oscillation come under the category of the periodic motion. Okay, but are the periodic motion not come into category of the oscillation? Understand this. Sir, the motion of the watch in wall watch, is this oscillation? No, sir, because the minute or the hour needle continuously rotating in one sense. It does not perform to and fro motion. It continuously moves either clockwise, then clockwise. So this is a periodic motion, but not oscillation. So I hope this is clear to everyone. Okay, beta. So that's it for today class, and let's meet tomorrow with some new concept, and we are going to understand how we can apply this equation in numericals also. So thank you so much for attending the class.